Today I woke up with something on my mind. I want to build something, but something big. Iron Man, my favorite superhero. And he is because he has Dummy, which was an articulated robotic arm and was, well, anyways, dummy. And I want to build one for my desk, but I also want to look like an industrial robot. Or even better, I want to give it a slightly more evil look. Yes, it's time to get started. The first thing I want to do is build a solid base, since I'm tired of all my projects looking like crap. And the next day, with the dry mix, all that was left was a quick cleaning, and now I guess the base is ready. Oh, by the way, I also left a piece of the mix to test how strong and resistant the cement was. And well, since the test was just hitting it, I guess the base is quite resistant, so we'll move on to the next thing. And now what I want to know is how I'm going to build a robotic arm. To be honest, I'd never built one before, but some things I want are for it to have a very elegant design and fit on my desk. And another thing I want it to have is 6 degrees of freedom. I have no easy way to explain what I'd use it for, but to give you an idea, it's like the Chuck Norris of robotic arms, meaning it has no limitations on where or how it wants to reach a point in space. But let's start with the first axis, which will be the one that rotates the whole arm, although there is a small problem. To do this, I need a giant bearing, which I don't have, and don't want to buy either. And to solve this, I will involve my steel balls, or ball bearings, whatever you call them, although more than half were rusty. And this is the first version of my bearing. And when I started assembling it, I noticed that, well, that shouldn't have happened. So this is the second version of the bearing. I added a little hole to make it easy to assemble, although it still couldn't spin the way I wanted it to, so I adjusted the tolerances, and now it spins the way I want. Although now I just need to make it bigger, and I just need to attach it to the motor. It's a good design, so I can do whatever I want. Since I have the first axis built, which is equivalent to the first degree of freedom of the robot, I noticed something interesting. These motors are extremely precise, so I can leave this here, make it spin a few times if that's absolutely necessary, and then have it come back, and it will know exactly where to stop to return to the starting point. Well, the motor doesn't actually know, but I'll explain that to you later. So now let's move on to the... And to build the shoulder, I need to place the motors around here. And another unremarkable thing I noticed about these motors is that they are ridiculously weak. So it's not like I can put the motor there and expect it to move the whole arm, because if I try to do that, it will most likely fall. And to greatly improve the motor's strength, I have a solution. A mechanical actuator, but with planetary gears. And that way I'll increase its strength. But then I started to see a problem. My printer started printing all the parts crooked again. So I had to switch to a slightly more humble color. And now that we've put the motors on steroids, we can start thinking about how to actually make the shoulder. So I designed these two supports, and finally the shoulder. And I know it looks like a piece of plastic, and it is, but it has several things that are going to make it indestructible. And the first thing is that since I want such a compact design, I designed it in such a way that the reducer fits inside the shoulder. And to further increase the motor's strength, I decided to add a second stage of planetary gears, but I decided to anchor the planets and let the outer ring gear rotate. Which I hope will make the arm extremely resistant, and I also added a few more things, but you'll see them as I build it. And finally with this, we have the first joint, which seems to work well, but I still need to test its strength since this one should be the strongest of all. So I tried with pliers, but it was apparently nothing for my design. So I decided to assemble it with the base and bring it something its size. And after those tests, I noticed that even the drill was falling short. And another thing I wanted to achieve with this design, apart from a lot of strength, was for it to look quite elegant. Whistle. And since the design doesn't have protruding parts or exposed motors, I think for my first design I did well, but nobody cares about that. So Mr. Producer, let's move on to the next joint. And now, since I don't have any money, as always, I'll use steel rods for the structure since I don't want to spend so much filament on a piece of plastic. But someone very stupid forgot to make these holes in the same design. Since the shoulder design came out well, I plan to replicate and miniaturize it for the elbow. Although when I tried to do it, my printer started failing more than usual. So thanks to my parents, I can now print all my designs with good quality. And now, since I built the elbow, the robotic arm is taking shape, and I know you're going to tell me, Gabriel, looks like a damn gear shift. And I know I have no way to contradict you, but there are still several parts missing, and this is not the final design, so let's go straight to the fourth axis. Although I had to take the elbow apart again, since I need to pass some cables through there, and to your surprise, what we are going to assemble is another planetary gear. But now that it was taking shape, I felt a bit bad about continuing to hit it with the hammer, and since this motor is smaller and therefore weaker, the reduction it has is larger for its size, although that doesn't mean it will be less resistant than the others. But when I started assembling it, I remembered something that was missing. And since all the custom bearings I made can't be taken apart, please, Mr. Editor, rewind time a little. And now, yes, right here, a couple of bolts were supposed to go, and with that, we can assemble it. We would have the first stage of the reducer done. And you know it has a lot of force when it can do this to your finger. And now all that's left is that another stage, so it goes from crushing fingers to crushing hands to crushing hand. And along with that, one of my bearings. And finally, the output of the fourth axis. And now we just need to put some balls in there and a few more in the other joints, since according to my design, the joint has a giant bearing, so they move like butter, And although mechanically speaking, we are doing very well, and all the designs I'm making are turning out just as I wanted, I started to notice a very serious problem. Well, in fact, there are several problems. First, if I currently have 4 axes and am planning to build 6, and the board I'm using to control the arm at the moment barely has enough to control 2 motors, how the hell do I plan to control the whole arm? And another thing, even though my reducers are very compact and resistant and also very strong, they are extremely slow, so I need a way to improve and control all the motors at the same time. And designing a circuit like that would take an engineer months. And I think you've already noticed I'm not even an engineer, but it gets worse. Doing something like this on the first try without anyone's help is very difficult. And it seemed like I had done all of this for nothing. Just kidding. I know exactly what to do. finally, after countless hours of design...
But it's only been 2 days.
Shut your mouth, bro. And as I was saying, thanks to Flux AI, I was finally able to finish building the board. And remember that you can also try Flux to make your circuits using the link in the comments So after a few days or several weeks, I finally had my designs at home. Although I'm a bit scared, it really is the first board I've made in my whole life. But since we were going to build it anyway... And this is where I noticed the first problem. I designed this board for an ESP32, but not the ESP32 I had, so I had to improvise. And now I made a page to control all the motors, and since I wanted to test, if we improved the strength and speed, I added something heavy. And now my gearbox will be stronger and faster, although I think I went too fast, but I'll fix it with a bit of code. But I want to build the wrist, the gripper rotation, and whatever's going on the gripper right now. And now we finally have a 6 DOF arm, although several parts are still missing, but at least the mechanical part is finished. And it seems the wrist joint works well. But I'm still afraid to turn on all 6 motors at once because the board has been giving me some trouble. But I really want to start playing with the robot, so I'm going to have to finish building the chassis. But there is something else I want, an infinite rotation gripper. But for that, I first need to make the motor stronger. And for the infinite rotation, I have a fairly simple plan. And for this, I need a PCB, or, well, what was left of the PCB, on which I cut several rings and connected some wires. What I'm gonna do is have a ball bearing pass through each of these tracks, which I hope will let me carry current from one side to the other without friction. And that part will go right here. And I left a hidden compartment for the cables to pass through. Although I don't know if putting the motors in the front will create so much leverage that it makes the arm weaker, but I want to start seeing how much it can carry, but I want it can carry. Usually arms of this size with so many degrees of freedom can barely carry 200 G. So we'll start with something light, 400 grams of electrician's pliers. And how does it carry? Easy. What's more, I don't think it even feels it. Now I'm gonna try something a little heavier. 800 G's of a carpenter's hammer. Well, I think once again it doesn't even feel the weight. And I think I could load even heavier things, but for the sake of the joints, which are made of plastic, and because I need to do more tests, I won't do it. Although the most I've been able to carry is a drill or a full bottle of a peculiar liquid. But the truth is, I still don't know what to put on the tip, and I'm looking for something more interesting than a clamp. I found some small gloves, but obviously it wouldn't weigh anything to it. But this gave me an idea. Since I'm controlling it with keys, it's moving a bit slowly, so it would be a good idea to create an animation system instead of moving every motor one by one. But these gloves didn't convince me entirely either, so I found some larger 18-ounce ones. Like what Mike Tyson used, though it could easily be Mike Tyson, not because it's strong, but because it's the color N. And now I ask you, have you ever played Fruit Ninja? Damn. Well, I don't think you're cut out for this, but after that I came up with something. Adding a laser, but a high power one. You know, the kind that can do that. And I designed a mount to attach the laser. Now, I know it looks like it has the aesthetic of a weapon of mass destruction, or maybe that's just my imagination, but what I need now is to build a system to control the arm. What I wanted to do is have it mimic my arm, but that would get uncomfortable pretty quickly. So I went back to the idea of making simple animations, where I program the movements and then it repeats them, or better yet, make them random. And for that, this time I did it in Python instead of directly on the ESP32. But to test the precision and effectiveness of this, I need to try it against some enemies, but I also need to take it somewhere a bit more open and with less wind. I think someone thinks they're Godzilla, although I was having some problems since I started doing the animations and the motors kept getting stuck and wouldn't reach where I wanted. To be honest, I don't know if it's the animation system or the new Python code, because I couldn't even do what seemed easy before, or
The truth is, I was really tired of this project, so I had to give it my final push.
What I want to do first is regain the motor's strength, and I already realized why this happened before I sent commands directly to the board. But that made the ESP32 act dumb because it had to process what it had to do before doing it, and it ended up getting saturated. And that's how the Python code came in, doing all that work and sending it to the board. But that was exactly the problem. Python is sending thousands of data points per second, most of which are being lost, and the little that does arrive
Makes the ESP32 completely lock up.
To fix it, I sent all the data in blocks. It was actually harder than I explained, but thanks to that, I can now move all the motors simultaneously and create slightly more elegant animations. And I can also make more iconic poses now. And this also paved the way for much more aggressive acceleration ramps. Or even more complex movement math, and obviously I also regained all the arm strength I had lost. I also managed to create extremely complex animations, and when I wanted to check the motor temperature, I realized something. They were very cool, which means I can keep it dancing for hours or maybe even days. But for it to do that, I came up with one last idea. I redesigned another board in Flux, and what does it do? It measures the exact position, angle, or acceleration it has, which will allow me to map what the robotic arm is doing and perform the same movement thousands of times without losing precision. I also designed a gripper for it, but the arm is so strong that any gripper I tried to build couldn't take full advantage of its strength and would end up turning it into a regular arm, so I simply discarded the idea. Do you feel like building it yet? Guess what? I'm giving away the designs. Yes, a month of my work for free. Why? I don't know, but what are you waiting for to subscribe?